Insight, NASA's Mars robot's goodbye message. One of NASA's robots on Mars, named Insight, has had significant dust collected on the solar panels and as a result, is about to die, if not already. It sent home one final message and image, saying this: "My power is really low, so this may be the last image I can send. Don't worry about me, though. My time here has been both productive and serene. If I can keep talking to my missions team, I will, but I'll be signing off here soon. Thanks for staying with me." Welcome to another episode. If you enjoyed this type of content, then subscribe and hit the bell icon so you never miss out on any of our latest and greatest uploads. A robot on Mars ended its successful science mission with a poignant social media post. Insight, a lander that's been on the Red Planet since November of 2018, signed off with one final message below. Its solar panels are covered in Martian dust and it cannot recharge or send more messages back to Earth. The goal of this NASA robot was to track Mars quakes and learn about the planet's molten core over the course of 2 years. The last time NASA was able to communicate with Insight was December 15, 2022, just over 4 years from its landing. Farewell, and congratulations on a job well done, Insight. We won't worry about you, but we will think of you fondly. The lander also carried names to the Red Planet. The supporters that list represents are likely not the only ones sad to see Insight sign off for the last time. Its well-deserved retirement is a bittersweet occasion for the science team. It's also not the first time an anthropomorphized NASA robot has made us sad. Back in 2018, the rover Opportunity signed off with a last message of, "My battery is low and it's getting dark." That machine, designed for a 90-day mission, operated for nearly 15 years. And then there's the Curiosity rover, which sang happy birthday to itself back in 2013. But Insight's final message really does hit hard. NASA Jet Propulsion Laboratory. InSight stands for Interior Exploration using Seismic Investigations, Geodesy, and Heat Transport. The various probes and measuring equipment recorded Mars quakes and weather changes over the years. The information about tremors helps scientists to understand Mars's interior, including the planet's mantle and crust. While it's sad to see InSight sign off, the Perseverance rover and Ingenuity helicopter are still working hard on the surface of Mars. The news, which we saw thanks to Kotaku, comes as NASA plans more missions to the Red Planet. The agency plans to return samples from Perseverance, and the Artemis missions to the Moon act as training to land the first people on Mars. Insight, studying the inner space of Mars. Insight, short for Interior Exploration using Seismic Investigations, Geodesy, and Heat Transport, was a Mars lander that gave the Red Planet its first thorough checkup since it formed 4.5 billion years ago. It was the first outer space robotic explorer to study in depth the inner space of Mars, its crust, mantle, and core. Studying Mars's interior structure helps answer key questions about the early formation of rocky planets in our inner solar system, Mercury, Venus, Earth, and Mars, more than 4 billion years ago, as well as rocky exoplanets. InSight also measured tectonic activity and meteorite impacts on Mars today. The lander's cutting-edge instruments were designed to delve deep beneath the surface and seek the fingerprints of the processes that formed the terrestrial planets. InSight's task? To track the planet's vital signs, its pulse, seismology, temperature, heat flow, and reflexes, or precision tracking. The mission was part of NASA's Discovery program for highly focused science missions that ask critical questions in solar system science. First, CubeSats to deep space. The rocket that launched InSight also launched a separate NASA technology experiment, 2 mini spacecraft called Mars Cube 1, or MARCO. These briefcase-sized CubeSats flew on their own path to Mars behind InSight. Their goal was to test new, miniaturized deep space communication equipment. Upon their arrival at Mars, the twin MARCOs successfully relayed back InSight data as it entered the Martian atmosphere and landed. This was the first test of miniaturized CubeSat technology at another planet, which researchers hope can offer new capabilities to future missions. InSight Science Goals. InSight sought to uncover how a rocky body forms and evolves to become a planet by investigating the interior structure and composition of Mars. The mission worked to determine the rate of Martian tectonic activity and meteorite impacts. The InSight Mars lander had two science objectives that supported the mission's science goals. 1. Formation and evolution. Understand the formation and evolution of terrestrial planets through investigation of the interior structure and processes of Mars. 2. Tectonic activity. Determine the present level of tectonic activity and meteorite impact rate on Mars. Why Mars? Previous missions to Mars investigated the surface history of the red planet by examining features like canyons, volcanoes, rocks, and soil. However, signatures of the planet's formation can only be found by sensing and studying its vital signs far below the surface. In comparison to other terrestrial planets, Mars is neither too big nor too small. This means that it preserves the record of its formation and can give us insight into how the terrestrial planets formed. It is the perfect laboratory from which to study the formation and evolution of rocky planets. Scientists also know that Mars has low levels of geological activity. But a lander like InSight could also reveal just how active Mars really is. InSight. For 4 years, InSight was the only active seismic monitoring station beyond Earth. The lander monitored Marsquakes, providing details on Mars's interior, formation, and activity such as meteor impacts. The mission ended on December 21, 2022, after mission controllers determined the solar-powered spacecraft ran out of energy. In depth, Mars InSight. NASA's InSight, short for Interior Exploration using Seismic Investigations, Geodesy, and Heat Transport, is a Mars lander operating on the surface of the red planet since November 26, 2018. Its mission is to give Mars its first thorough checkup since the planet formed 4.5 billion years ago. InSight is the first robotic explorer to make a detailed study of the inner space of Mars, its crust, mantle, and core. The lander has cutting-edge instruments to delve deep beneath the surface of Mars to measure the planet's vital signs. Studying Mars's interior is helping scientists answer key questions about the early formation of rocky planets in our inner solar system: Mercury, Venus, Earth, and Mars, as well as rocky exoplanets, planets orbiting other stars. Specifically, the InSight mission seeks to uncover how a rocky body forms and evolves to become a planet by investigating the interior structure and composition of Mars. In January of 2021, InSight's MOLE ended its journey on Mars. Starting on February 28th of 2019, the probe attempted to burrow into the Martian surface to take the planet's internal temperature and provide details about the interior heat engine that drives Mars's evolution and geology. But the soil's unexpected tendency to clump deprived the spike-like mole of the friction needed to hammer itself into a sufficient depth. After getting the top of the mole about 2 or 3 centimeters under the surface, the team tried one last time to use a scoop on InSight's robotic arm to scrape soil onto the probe and tamp it down to provide added friction. After the probe conducted 500 additional hammer strokes on January 9, 2021, with no progress, the team called an end to their efforts. Part of an instrument called the Heat Flow and Physical Properties Package, or HP3, the mole is a 16-inch long, or 40-centimeter long, pile driver connected to the lander by a tether with embedded temperature sensors. These sensors are designed to measure heat flowing from the planet once the mole has dug at least 10 feet, or 3 meters, deep. Quote, "We've given it everything we've got, but Mars and our heroic mole remain incompatible," said HP3's principal investigator, Tillman Spohn of DLR. "Fortunately, we've learned a lot that will benefit future missions that attempt to dig into the subsurface." While NASA's Phoenix lander scraped the top layer off the Martian surface, no mission before InSight has tried to burrow into the soil. Doing so is important for a variety of reasons. Future astronauts may need to dig through the soil to access water ice, while scientists want to study the subsurface's potential to support microbial life. InSight also is measuring the tectonic activity and meteorite impacts on Mars. The spacecraft brought the first seismometer to Mars, the Seismic Experiment for Interior Structure, or SEIS. Provided by the French space agency, Centre National d'Études Spatiales, or CNES, the seismometer detected its first Marsquake on April 6, 2019. and has recorded more than 730 distinct Marsquakes as of mid-2021. About 35 of those, all between magnitudes 3.0 and 4.0, provided the data for 3 papers published in July 2021 that provide new details on the depth and composition of Mars's crust, mantle, and core, including confirmation that the planet's center is molten. Quote, "When we first started putting together the concept of the mission more than a decade ago, the information in these papers is what we hoped to get at the end," said InSight's principal investigator, Bruce Bannert, of NASA's Jet Propulsion Laboratory in Southern California, which leads the mission. This represents the culmination of all the work and worry over the past decade. The InSight mission's Marsquake service, which monitors the data from SEIS, is led by Swiss Research University ETH Zurich. InSight also is providing daily weather reports from Mars. This public tool includes stats on temperature, wind, and air pressure recorded at InSight's landing site. The tool was developed by NASA's Jet Propulsion Laboratory, or JPL, in Pasadena, California, with partners at Cornell University and Spain's Centro de Astrobiología. JPL leads the InSight mission. Through a package of sensors called the Auxiliary Payload Subsystem, or APSS, InSight is providing around-the-clock weather information. The lander records this data during each second of every sol, a Martian day, and sends it back to Earth on a daily basis. Wind sounds on Mars. InSight sensors captured a haunting low rumble caused by vibrations from the Martian wind, estimated to be blowing at 10 to 15 miles per hour or 5 to 7 meters per second, on December 1st, 2018. The winds were consistent with the direction of dust devil streaks in the landing area, which were observed from orbit. And with that, we've reached the end of this video all about InSight, NASA's Mars robot's goodbye message, and its accomplishments. If you enjoyed this video and found it helpful, don't forget to leave a like and subscribe for content just like it.